This exercise is a little bit different than others. As you can see, there is a slideshow to introduce it rather than just a little, how to say, a little Word file. So that's not the only difference. What's going on here is that this is really not an exercise. It's more like an activity that is guided step by step. Okay. The purpose of this activity is to give you a sort of immunization booster shot on the different type of errors that you are going to encounter all semester long. And actually preparing you for those errors with the C language is going to still have an effect of teaching you how to read compilation, linkage, and runtime error, identify them as such, and be able to develop debugging skill in different languages. Okay, so that's what we are going to do. I'm going to just like run you through the slide real quick so that you understand how to use them, and then you will have to follow them at your own pace one by one and do the manipulation that I requested of you in the slides. Okay, so we're going to just go for an overview of this slideshow, and then you will be able to work on it by yourself. So we're going to cover three different types of errors: compilation error, linkage error, runtime error. If you're not clear about the difference between those, you need to ask questions in the forum, contact me by email, contact the TA or stuff like that. It's really, really important. So there will be a section on understanding runtime errors. Well, that section is going to start easily. Okay, I'm giving you a piece of code here, and I'm asking you to type it and to run it and to debug it pretty much. I would really suggest that as a first step, you look at it and you try to debug it by really observing it, trying to look for errors, especially the errors that were indicated in the textbook, and try to run it in your head to make sure that you can identify the 4 different errors that are present in this code. Watch out when you open the slideshow on your computer. The 4 errors, the solution, are actually available right here. They are available in the comment section of the slide. So when you open the slideshow, you can read directly the comment section and nod and say, well, yes, of course, I would have found those errors myself. Well, no, you wouldn't have necessarily. That's why it's good to train. Looking at the result, the end result is always easy. Trying to figure it out by yourself is when learning happens, is when you have questions, etc. So don't look directly at the solution. Okay, I trust you, you're adults. Try to work on the slide and then look at the solution to help you out if you miss a couple of the errors. So this is going to be the first activity you are going to do in this series. Then we are going to move to understanding compile time errors. Okay, so this slide is just stating what is the purpose. I already tried to cover that. This expression here is interesting, trying to learn to think as a compiler does. Well, compilers do not think much, but the idea conveyed here is that you need to be able to understand the compiler. The compiler is not going to understand you, but you can make an effort to try to understand what the compiler is trying to tell you, and the more you understand it, the more you are going to be efficient at debugging. So this is how the activity will go after that. I give you some code, so same thing, cut and paste it, okay? Test it, run it, and then I'm going to ask you, this code should work, but I'm going to ask you here, for example, to remove this semicolon. Okay, remove the semicolon, compile again. I want you to learn how the C compiler expresses some errors. Sometimes it's going to be really straightforward and the message from the compiler is going to be really meaningful. Sometimes a missing semicolon can lead the compiler to be confused about the meaning of your code and therefore output a wide variety of error messages. Well, the idea here is that you need to be exposed to those weird error message so that next time you have a problem unsupervised when you are programming, you will say, well, I already encountered that. I saw that in the exercise. That just means that, maybe a semicolon is missing. And this is how you are going to build experience. This is how you are going to build a little bit of confidence in interpreting the error messages from the compiler. Okay, so there are going to be a series like that of manipulation, okay, experimentation. Remove the closing command, remove the closing command, but this time watch out, there is another command in the file. So how does that act with the compiler, or how does that interact? Remove the double quotes, okay. Remove the double quotes, but this time, and this is like a typo, this should look like a regular double quote. Remove the double quotes here, but this time there is another string in the next line. So how does that work out, okay? And etc. There is a string on the same line. How does that work out? The error message that the compiler will output are copied as a in the comment section of the slide again. So no point in looking at them. Experiment, this is how you're going to learn, but they are there just for your preparation for the final, etc. later on. One thing to note is that the compiler modified the scripts recently. The compiler that you are using right now is going to produce probably more verbose error messages. I turned on all warnings, so you might have slightly different result, etc., etc. Remove this, remove that. The second part will be understanding link time error. Second or third part, I lost the count. Linking errors, we are going to misspell printf, for example, put an uppercase P. Okay, we are going to remove pound include. We are going to call a function do work here that we never define anywhere. And we are going to, and this is it for the linkage. Okay. Now this last slide here is going to open up questions. I want you to try to solve those questions. Of course, the forums are there to help you. So you will have a forum for exercise of Module 101. You can post those questions and your basic understanding on them and try to find with your peers complete solution, and I will help you, of course. But these are meant to make you reflect a little, think about what is a library. How does linkage step play with library? What is the role of pound include statement? How do they relate to libraries, etc. And then we'll conclude with a little, a little experience which I'm going to comment. Okay, this experience is here to generate an executable based on a program which we called void.c that contains nothing, just a main. Okay, and that's it. Nothing. The main doesn't do anything, it just returns 0. And we are going to compile using GCC and using different option static, no option static. Okay? And then I'm going to ask you to look at the size of the generated files. And the open question I want you to think about and work on with your peers on the forum is, how do you explain that first, an executable that does nothing, okay, this is a source code, an executable that does nothing, like this one, and this one, have a size which is not null. Okay, and actually it's not even not null, it's quite consequent. 13 kilobyte and more, 167 kilobytes. So question one, why so big? It doesn't do anything. Question two, okay, and what about the difference between this thing called dynamic linking? I'm going to go back one slide. Okay, what about this option here that allow me to do static linking and the default option which is dynamic linking? What explains the difference between dynamic and static linking, and what does that correspond to? So do a little web search there. Do a little web search, try to find some information, post your question, your thought on the forum, and let's try to come to a solution together. Just for your information, this is an empty program. This is a hello world. Look at the difference. Almost no difference in the final size, really neglectable. Okay, so why is a void so big? This is the first question. What is the difference? What explains the difference between the static linked version and the dynamically linked version in terms of size?